This is the observation deck, and we're with Shaun Killa, who is the director and the head of architecture for Atkins Middle East. He comes from one of the more fascinating architectural cities on the planet today, Dubai, in the United Arab Emirates. And he is here in Chicago to pick up the Tall Building Award for the Bahrain World Trade Center, which we're going to talk about. A stunning building and a very revolutionary design. Shaun, tell me about Dubai. I mean, that's got to be a fascinating place to work.
Yes, it is. In fact, I went to Dubai about 10 years ago and worked on the Burj Arab for some time. And then after we finished that, we won several international competitions, and one of the first ones I won there was the 21st Century Tower, which was the tallest residential building in the world for 4 years, which was 270 meters. And then soon after that, the Chelsea Tower, 250 meters. And soon after that, about a year after that, the Almas Tower, which is just about complete now, which is 370 meters. And so it just led on that this was the period also just before the government allowed expats to be able to buy. And as soon as that went through, then there was the so-called boom, which started about 5 or 6 years ago. And we were well placed at that time, having done a number of other high-rise buildings just before, to take advantage of that period. And I think in the last 7 years, we've probably done 35 or 38 high-rise buildings above 50 floors.
And what was the average height of some of those?
It was anything between 50 and 70, 80 floors. So now we're working on a particular project of about 140 floors.
Because you were so well positioned, being literally in the right place at the right time, I don't know that any architect necessarily sets out to design super tall buildings, but all of a sudden you found yourself in that market and winning jobs. How does that happen?
I think that in understanding not only the design ethos of what clients are looking for, but also understanding the technicalities of putting up high-rise buildings, and that things like efficiencies, especially knowing as much as one can about MEP systems and structural systems to get the efficiencies from, say for example, even 70 to 78, even 80% makes all the difference to clients. So the challenge really is to create buildings which are timeless, which aspire to the client's point of view of being a reflection of themselves, but at the same time being highly commercial because of the cost of them, and of course by getting the right efficiencies in the building, you can make literally his business case work.
I think a lot of people on this side of the planet, when they think about Dubai, think about number one, it being one of the energy centers of the world, and gee, there must be a lot of money floating around just with the kind of buildings they're putting up, and the size and just the total value, the total monetary amount of what's going on over there. But what's it like to work on projects in Dubai and to have these people as clients?
Well, say 5 or 6 years ago, when or just before the boom, we were dealing directly with the owners. After the boom, because of the number of projects that were in play in Dubai, organizations and development companies got so big that in many respects you started dealing with client representatives because they had such an enormous portfolio of work. And that also became challenging because somehow the direct contact that you have with the client started to diminish. So, and the speed of the projects, so many clients were looking for turnarounds within 2 years of being able to get from design almost to near completion on a building. So our design times were challenged, and that was very, very difficult. And fortunately, we had all the right people in place that had done many high-rise buildings that could turn around the designs very, very quickly compared to perhaps in the UK or even in the States.
So it's a very fast market.
Yeah.
One of your projects is the Burj Al Arab, which people would probably recognize as kind of a sail-shaped building, kind of a wedge that is a hotel, and probably, would you agree, the world's most opulent hotel. The pictures that we see of the interior of that building are just amazing to look at because it is so lush and opulent, and I think people must think that when you go into Dubai and you're given a budget for a building that you can do pretty much anything you want or anything that you can think of, but that's not really the case because you have to build a business case for them too and really adhere to the same rules that everyone else does, even though you have quite an affluent client.
That is true. With the Burj Arab, I wasn't the designer of that building, Tom Wright was, but worked on the project, and we had a very strict budget. It was exceeded, but not tremendously, and we had a much calmer interior initially, and the client, after seeing the mock-up, was interested in a far more opulent interior to really show off the sort of the jewels of the Middle East. But it is right that we have very strict budgets to adhere to and timelines. However, what Dubai has realized, and the clients have realized in Dubai, is that by giving, say, 5 or 10% more on the budget to create something which is somehow a bit different, their returns are greater than that 10%. So ordinarily in a lot of places around the world where the budgets are so tight that they literally become non-buildings, where they've seen the benefit perhaps of spending a bit more.
The Bahrain World Trade Center, what's the status of the building? Let's just stay away from the microphone. Is that actually completed now?
Yeah.
Okay. The Bahrain World Trade Center in Bahrain, the United Arab Emirates, a stunning building, kind of a revolutionary design that has wind turbines in it, and I'll let you describe it here, but when we talk about making business cases for a client, you have sold an energy efficient building in probably one of the energy richest areas of the world, which I think is no small accomplishment. It's like selling refrigerators to people in Alaska, selling freezers to people in Alaska. Describe the project and why, how did you sell this to this client?
Well, first thing is that Bahrain is actually not rich in oil. It's one of the few states in the whole of the Middle East which has very little. So, but nevertheless, it is an oil-rich region, and most clients, even if whether they have or haven't, they still have an ideal that there is energy, for the next 100 years. So, but going back to the building, in November 2003, we were called over to Bahrain to look at a site which had an existing hotel, shopping center, and an office building, and an open lot in front of it, in the middle of the old part of Bahrain. And in walking around the site, as any typical architect does, taking some pictures before heading back to Dubai, I noticed there was tremendous wind blowing. And being a sailor for, I think back then probably 22 years, I immediately recognized the wind direction and the wind speed, and thought for myself, I'll be far better in Dubai, perhaps on my boat having a good sail. So when getting back to Dubai and start looking at the project, the brief was quite simple from the client. He wanted an office building and for us to extend the shopping center in the way that we master planned the site. And 2 years prior to going to Bahrain, I started researching wind turbines and how to integrate them into buildings. And I used to work with a lot of our wind consultants on a number of the wind tunnel tests, and optioneer with them just in terms of sketches. So when this opportunity came about, and the site was so perfect that it had unobstructed winds coming straight off the Arabian Gulf. And in looking at the windrows for Bahrain, I noticed that 70% of all the wind energy came from the northwest, which was directly perpendicular to the site. And in starting to master plan the site, with the extension of the main mall of the existing shopping centre into the new one, it started to show that there needed to be a twin tower situation over that axis, which is once again perpendicular to the wind. So we put together a concept design and an animation and went back up to Bahrain about a month later, and we did a presentation to the client with full animation of this building with the wind turbines turning and so on. And to the client's credit, he fully embraced the project and he absolutely loved what he saw. So we got back to Dubai, and before we knew it, I think the next weekend we were told that there were bulldozers on site removing some of the existing trees and rubble, and that they wanted the basement drawing, and we had literally just finished the pre-concept. So it became a fast-track building of note. However, what was so interesting about this particular challenge was that wind turbines had never been put on any building before. And from that point, I started about 6 to 9 months worth of research. First of all, with wind turbine manufacturers. And a lot of the big manufacturers are into much larger turbines these days than 30-meter turbines. So they were less interested. And it took a long time to find the right partners, really, to be able to design the bridges and the turbines together. So eventually we found partners from Denmark, in fact Norwin and Randall, to help us put the design together as a sort of a design and installation commissioning agent. And that was where the breakthrough was, and the client asked us to do a full feasibility while we were doing the design of the building. And during that time, they came over and the client asked them a very frank question. He said, "Is it possible?" And they said to him, "It is possible. All it is taking two existing well-known technologies and putting them together in a unique way." And of course then they went away and did 6 months worth of research, of which we had a number of people in Atkins as well that work on airplane wings and vibration analysis and so on. We did over 250 cases of SAM analysis, looking at reflections, looking at bird strike, looking at noise, vibration, all sorts of things. And then we had another team that was constantly looking at each one of these issues and engineering them out. So by the time the feasibility was finished, and when it got the tick in the box to go ahead, in fact it was almost fully engineered, and there just needed to be the detailed design. So at that point we were actually well out of the ground. We had allowed for the extra loading on the piles and the core to take the bridges and the turbines. So it was a tremendously exciting time to incorporate. I mean, these turbines are very large. They're 29 meters in diameter, which is almost across a football field.
Well, and these are the kind of wind turbines that have sprung up all over Europe and that are springing up in the United States, and that they have 3 huge propeller blades on them.
Yes.
That's the kind of turbine we're talking about.
I mean, each of them produces 225 kilowatts. So the building, in terms of renewable energy, the building's producing very close to 700 kilowatts of energy peak, which is probably more energy than any other building has achieved.
Well, what really fascinated me to hear about this building is that the wind turbines are not tied into any kind of grid. So any energy they produce is used solely for the building, and at those times when the building is closed at night, you know, in off-peak hours, you're finding ways to store and reuse that energy without batteries. How does that work?
Well, it is actually connected to the grid on the low voltage side of the grid. But when we presented this project 4.5 years ago to the local authorities, the power authorities, of course this was so unique to them that they asked us to put in measures that would prevent it exporting out of the grid. So what happens is each turbine is connected to a different busbar riser in the building. So as the energy is being generated, it's being used immediately by that particular busbar that's feeding the tower. However, during the commissioning phase of the turbines, which was in April, March, April this year, the manufacturers came to the understanding that it's going to produce quite a lot more energy than we anticipated. So we're going to be monitoring the energy yield, especially over weekends, and how many times the turbines may have to shut down, because what happens on weekends is it's an office commercial building, so on weekends the building actually shuts itself down, and if more energy is being produced than being used in the building, then the BMS system of the building actually tells the turbine system to go into a shutdown mode. So we'll monitor this energy or the loss of energy perhaps for some time, and then there's either we will represent the scheme to the local energy providers and ask them to remove the CCU unit in front of the transformer and allow us to export energy like they do in Europe and many other places around the world back out to the high voltage side. If they don't, then what we will do is we will take a part of the basement, which is part of the basement where there's car parking in a less efficient, maybe dead-end area, and create a reservoir and get 3 chillers and actually create ice. And we will run the chilled water system of the building in coils through the ice. So over the weekends, the turbines will make the ice, and then the first day or two of the week when the building is occupied, the reservoir of ice will subsidize the chilled water system in the building, and obviously therefore take less energy from the district cooling system. And the advantage of using ice as a battery almost is that whether you're using fossil fuels, be it coal or oil, to create the ice, or renewable energy, both of them use the same amount of energy. So in other words, there's no loss of phase change like you would have for batteries.
So a lot of people might not think of ice as being a sort of battery, and that's essentially what this is that you don't need a battery to store energy. You can store it in the form of ice and use it later.
Well, exactly. The issue is that, first of all, batteries are not sustainable. And second of all, if you're producing 700 kilowatts peak, the amount of batteries you would need would probably fill the basement. So it's just, it doesn't really sum up. And I mean, the building's design is very unique in the sense that what it does is it funnels the wind from the Arabian Gulf. In plan, and this is the success of the building in all. In plan, the 2 towers are shaped like aerofoils, like similar to the airplane wing, and they're also tilted towards the seaward side to funnel the wind from across 120 meters and funneling it into just 30 meters across. So this accelerates the wind speed between the 2 towers. At the same time, there's a negative pressure behind the building. So even the wind outside of the width of the building is wrapping around the back of the building to replace that negative energy, and in the same way is actually drawing more air from between the building. So we have this in terms of plan, and then in elevation, a lot of people ask me, well, why is the building tapered? And the reason for that is because the wind speed increases with height. And with the reduction of the building's width, it reduces the funding effect. So the net result, or the combination of the increase in wind speed and the reduction of the width of the building, allows each turbine to be running at exactly the same speed and producing the same amount of energy, which has tremendous amount of advantages, whereby there's the same maintenance regime on the turbines. They also visibly look satisfying when they're all running at the same time, and it's been it's overall tremendous success. Oh wow, yes,
okay, we're still here. What I was going to ask you was the orientation of the building. You're taking wind that is coming directly off of the water. However, does the wind direction change that much? And if it does, how efficient is the building?
Well, as I said to you before, when we check the windrows for Bahrain, the windrows indicates that 70% of the wind energy is coming directly from the northwest, and the building is facing northwest. So, for the majority of the time, except for just at about 4 o'clock in the morning, there's a light breeze from the other direction. At that time, the turbines wouldn't take that energy. But as soon as the sun comes up, what happens is the empty quarter in Saudi starts to heat up. So you get convection in Saudi of the empty quarter, and then you get this rush of wind coming up through the building itself. Now, on average, the wind speed in Bahrain is about 8 meters per second, and what happens is, because of the funding effect, it actually pushes it up to around about 12 meters per second, even more. And the maximum peak load of the turbines, when they're running at the full 225 kilowatts, is at 12 meters per second.
The Bahrain World Trade Center is a landmark, important, groundbreaking building because it is the first building in the world to incorporate large-scale wind turbine technology, which we're probably going to see a lot of in the future, but this is the first one to do it.
Well, yeah, that is significant. I think the biggest challenge for us is that it had never been done before, and there was nobody to phone, there was nobody to consult. So essentially, we hope that we've broken the ground for many developers and designers in the future, where they can perhaps even go to the project and show their developers that this can be done, and it is a way forward. It's not for everywhere, because certainly you have to have the right site, but it certainly is a way forward. I mean, the same way the Wright brothers took off for beach, and look where we are today. Well, maybe 50, 100 years from now, every building may need to produce its own energy. And there are ways that one would need to do that, and this is certainly one of the ways. So, but the significance for Bahrain, I think, is that the local population of Bahrain have entirely embraced and are enormously proud of the building, because they've come to realize that it is a world first, and that it is on the cusp of so many agendas around the world with regards to sustainability, and they have this. And in its context, being twin towers of 240 meters, in a context of perhaps buildings of 10 or 15 stories, the buildings stand out really well. And in perhaps another way, it was the catalyst, or it was one of the catalysts in the whole of the Middle East, where developers from other countries within the Middle East, like for example the UAE, Dubai, and some of the others, they started to ask questions about why this building was different. And perhaps buildings of the future don't necessarily have to be the tallest or the longest shopping centers or whatever. It will really be down to buildings that are highly sustainable, and that is where a lot of the developers are looking at a project like this one to see a new future of how they need to develop.
Talking about Dubai and this part of the world, the Arabian Peninsula, it's kind of surprising, I think, to some that as energy rich as this part of the world is, that this is also probably one of the richest markets out there in terms of people who want sustainable architecture, buildings that produce their own energy. And in Dubai, you have another building under development that you've designed that's 402 meters tall, which is roughly 1,318 feet, called the Lighthouse Tower. A very slender design, and another sounds like groundbreaking technology. Tell us about this one.
About a year and a half ago, the Dubai, or the DIFC, asked us to do, or to design a building of about 80,000 square meters of office on a very, very small site. And they asked for a building that would show them off, and they called it the Lighthouse Tower. And they gave us about 2 weeks to design the building. But there wasn't a mention of sustainability or LEED platinum at that time. And what we did was we changed the agenda. We've now, since doing the Bahrain World Trade Center and a number of other proposals for other clients, where we've really looked so much further into the technology, not only this technology, but so many others to lower the energy requirements for the building. What we did was design the building that essentially aimed to reduce its energy consumption by 55%. Its chilled water requirement also by about 50%, and its water requirements by 48%.
But what is so stunning about the building is it is so slender and so thin, and I don't think there's anything else like that on the planet, where you have a high-rise building that tall that you can be on a floor and have light coming in at you from two directions.
Yeah, well, that's perhaps the word lighthouse has extended itself from the design, where it now has three meanings. The first meaning is what the client initially asked us for, and that was a very tall building, which actually, through the cross bracing, the steel cross bracing, we've actually inserted the client logo, which is a diagonal on its side, with LED lighting. So in other words, at night time you'll be able to see the building very subtly, almost like a mashrabir type of structure, which would show off his logo. That was his meaning of lighthouse. However, because of the slenderness of the building and it being long and narrow, the offices are really about 80 meters wide and only 20 meters deep, so you're getting natural light in from both sides. So the requirement of having lights on is very, very little. And we've got monitoring systems throughout the whole building that switch off all the lighting, and then only the task lighting will be used. And in that building we've also got 16 double-decker regenerative braking elevators. So in other words, on the way down, the elevators are actually creating about 30–35% of the energy for taking people up the building as well.